Welcome back. In this video, we'll be dealing with how to approach calculations on pH and POH. Now look at the two questions on the board. That's what we'll be treating in this video. How do you approach the questions on pH and POH that you get them easily, that you don't have to stress yourself? Now look at the question 1. It says the H plus this hydrogen ion concentration. Now look at this sign, it means concentration. This hydrogen ion concentration in an aqueous solution at 290 Kelvin is 2.8 times 10 raised to the power minus 3 mole per dm cube. They now say calculate the pH of the solution and show whether the solution is acidic or basic. Now look at this question. You are required to do two things. First, you need to calculate the pH of the solution. 2, you need to show whether it is acidic or basic. Now let's take the first solution. Now don't forget, from the previous video I gave you some formula that pH equals a minus log H positive, that is a negative log of hydrogen ion. Now from here, pH equals minus log H positive. So when it happens like that, then our pH is minus logarithm of the hydrogen ion is 2.8 times 10 to the power minus 3 mole per dm cube. So now that's 2.8 times 10 to the power minus 3 mole per dm cube. So now when you do that correctly, when you press your calculator minus logarithm and this, then your final answer should be 4.55. Yes, 4.5. That's the power of our hydrogen ion. That's the power of hydrogen ion. So that should be 4.55. So now the second step, they now said show whether the solution is acidic or basic, and you have been given the ionic equilibrium of water. Now in the previous video I emphasized something that what did I say? I talked about relating hydrogen and hydroxyl ion. Now when hydrogen ion is greater than hydroxyl ion, the solution is acidic. So when hydrogen ion is less than hydroxyl ion, then the solution is basic or alkaline. So when hydrogen ion equals to hydroxyl ion, then the solution is said to be neutral. So now they said show whether the solution is acidic or basic. That means you have to determine the hydroxyl ion also and compare them together with the hydrogen ion. So now let's go. To do that, now you can easily do that from the ionic equilibrium of water. Don't forget I gave you a formula. Ionic equilibrium of water, that's ionic product of water, that's H, that's hydrogen ion concentration, multiplied by hydroxyl ion concentration. So now this is the relationship we use. Now if we are looking for hydroxyl ion, so if we make our hydroxyl ion the subject of formula, then our hydroxyl ion concentration will be ionic product of water over hydrogen ion. So can you see? So now when you do that, what you have finally is this. That will be our ionic product of water is 1 times 10 raised to the power minus 14 all over what's our hydrogen ion concentration. Our hydrogen ion, that's 2.8 times 10 raised to the power minus 3 mole per dm cube. Okay, this mole squared dm raised to the power minus 6. So now when you put 2.8 times 10 raised to the power minus 3 mole per dm cube, now what you get finally should be okay, that will be 3.57 times 10 raised to the power minus 10 mole per dm cube. So now this is what you get. So now look carefully. Now look carefully. So now look at the hydrogen ion. Hydrogen ion equals 2.8 times 10 raised to the power minus 3 mole per dm cube. Hydroxyl ion equals 3.57 times 10 raised to power minus 10 mole per dm cube. So now look carefully. Now look at the two. When you compare the two together, look at this one. This one is raised to the negative 3. This one is raised to negative 10. Now the lower the power, that shows that the larger the number. Now because the power of this one is low, if you press in calculator, you will discover that when you subtract this from this, you get a positive number. But when you subtract this from this, you get a negative number. So hydrogen is actually bigger. Look at the power of 3. This one is power of 10. Hydrogen is actually bigger. When you check on the calculator now, look carefully. When you press the calculator, so hydrogen is actually bigger. Now because hydrogen ion concentration is greater than hydroxyl ion concentration, then the solution is acidic. So can you see? That shows that the solution is acidic. So now that's that on that. Now let's move to question 2. The water sample has hydroxyl ion of 1.47 times 10 to the power minus 9 mole per dm cube. What is the pH of the sample? Now look at this situation. You have been given the hydroxyl ion. You are looking for, so first note what you are looking for. You are looking for your pH. Now when you are looking for pH, don't forget there is a formula that says pH plus POH equals 14. I think I released that in the previous video. I put it in the when I was in the description of the video because I couldn't remember to put it. Now look at it, pH plus POH equals 14. Now what's the next thing that happens? This is the first formula that should come to your mind, which means you need to know your pH and know your POH. Don't forget you are looking for pH, which is you need to know your POH to be able to get the final answer. So now another step is that you can easily know your POH from your hydroxyl ion concentration. How? Don't forget another formula that says POH equals minus log, that's negative logarithm of OH negative. Can you see? Hydroxyl ion. So now you can easily know your POH from here. So now when you do that, your POH, that's minus log of 1.47 times 10 to the power minus 9. A water sample has hydroxyl ion of 1.47 times 10 to the power minus 9. What is the pH? Now this is your hydroxyl ion times 10 to the power minus 9. Now when you press your calculator, you should have 8.83. So this is what your pH will be, 8.83. Then you can now go back to this formula. This is your first formula. So now when you put that, you are looking for your pH. Then pH, when you make pH the subject of formula, because you are looking for pH, so you finally have equals 14 minus 8.83. So when you do that, then the final answer you have 14 minus 8.83, or when you press your calculator, you finally have 5.17. So that's what you have finally, 5.17. That's what will be the pH of the solution. So thanks for watching. More problems are coming on other problems on acid base equilibrium. Don't forget to subscribe and share with others. Bye.